When we were looking at atoms early on in the course, we made a big deal of the energy of the valence orbitals. This energy affected many of the properties of the atoms. What we'll find is that this energy also affects the potential of a material. Let's consider atom X and atom Y, each of which has one electron in a valence orbital. When you see orbital diagrams like this, realize that there may be many filled orbitals at lower energy and many empty orbitals at higher energy. We're only showing the highest occupied orbital. And although there's only one orbital shown for each atom, as if it were an s orbital, the principles are the same whether the valence orbitals are s, p, d, or f. Let's consider what we know about the properties of X and Y. Remember that ionization energy is the energy it takes to remove an electron from the atom. Since the electron in X starts at higher energy, it will take less energy to remove it, and X will have the smaller ionization energy. Y will have the larger ionization energy. Electron affinity is the energy change when an atom gains an electron. Since the open space on Y is at lower energy, the added electron will experience a larger energy change, and Y will have the larger electron affinity. We know that electrons are attracted to the nucleus and experience what we called the effective nuclear charge. So we can now think about the positive charge that is felt by the electrons shown in the diagram. Coulomb's law tells us that if an electron feels more positive charge, it will go to lower energy. So the electron in Y feels a more positive charge. The electron in X feels less. So far, we have simply repeated the language we used with atoms earlier in the course. But now let's introduce a term that we'll use in redox. Since the electron in X feels less positive charge, we'll say that X has a less positive potential. The electron in Y feels more positive charge, so we'll say that Y has a more positive potential. Same trend, same concept, different term. Whether we talk about the positive charge that's felt or the potential, if you're more positive, you will be better at attracting electrons. So compared to one another, X will be poor at attracting electrons, while Y will be good at attracting electrons. The idea here is that if we have a measure of potentials, that will tell us about where the electrons would prefer to go. If we think about where electrons move spontaneously, we know that they will move to lower energy. But notice they also move to more positive potentials, and that should be easy for us to remember. Negative electrons are attracted to more positive potentials.